Okay, so in this video, we're going to look at trig with non-special angles. So those are the angles that exclude the ones that we mentioned in the previous video. So angles that are not 30, 45, or 60, right? So that said, here we have a perfect example. We see an angle of 25 degrees, and to do this, we're going to need a calculator to do this. Okay, so let's boot up our handy dandy graphing calculator. Let's see if I can bring it over here on this screen. Okay, and oh, maybe. Let's go ahead and get started though, so we can easily add and subtract from 180 to figure out what this missing angle is. That's obviously going to be 65 degrees. Okay, now we just need to find the missing hypotenuse and the missing leg here. And give me 1 second, having some goofs with some software. Okay, let me move my calculator over here for us to see. Okay, so actually, let me move it over here, like out of the way. Oh, of course, that's what it's going to do. Okay, there we go. Okay, so that's it. Okay, so I want to find the missing hypotenuse first. This all still works the same way. I can use sine of this 25-degree angle here. I can set it up as sine of 25 degrees is equal to opposite over hypotenuse. So in this case, that would be segment AB is our hypotenuse here. Okay, so that said, um, we don't have another cute ratio to put over here, right? There's nothing on our trig table for 25 degrees. So we're going to need to employ the help of the calculator and also just do some basic algebra. Okay, so it basically comes down to this. You're basically going to take sine 25, put it over 1, and you're going to go ahead and cross multiply as is, right? So now my algebra just becomes, it's still a butterfly. It's going to be segment AB times the sine of 25 degrees is equal to 400 times 1, which is just 400. We're trying to get AB by itself, so what we're going to do is divide both sides by sine 25. And what you do to one side, of course, you do to the other. And our missing segment, AB, is of course equal to 400 divided by the sine of 25 degrees. Okay, and what we're going to do is throw that into the calculator. So first thing I want to do is make sure that I'm in degrees mode. Okay, so you can see you can toggle that right up here on the top right, degree radian. Right, so right now I'm in degrees mode, and I'm just going to enter as is. So I'm going to hit Control Divide to make a fraction. Well, gee, I don't know, maybe. Okay, let's go to Add Calculator because it's being stupid. So let's try it again. Control Divide. There we go. And I'm going to say 400 over sine. So hit the trig button, hit sine, and then we're going to say 25 degrees. Okay, so that means we're about 946.48. So this missing hypotenuse here, AB, is about 946 points, and I already forgot, 48. Okay, and that would be the distance between those vertices A and B. Okay, so it really is that simple, right? And then if I wanted to go ahead and find the missing long leg here, CB, I could do pretty much exactly the same thing, right? Now, we want to avoid using this number just because we want to avoid using decimal estimates, but you can always copy and paste using the calculator, so not too big of a deal. But for all intents and purposes, I'm going to avoid that. So I'm going to go ahead and use this angle right here, this 65-degree angle here. I'm going to use that, and I'm going to say tangent of that angle is equal to opposite, which would be BC, which is the missing long leg that we're looking for here. So opposite over adjacent, right? Again, 65 degrees is a non-special angle, so I can't refer to my table. I'm going to have to use my calculator. And I'm going to multiply both sides. And we can see, we're going to cross multiply here, but it's obviously just going to be that we multiply by 400 on both sides. And we end up with our answer is going to be 400 times the tangent of 65 degrees. So 1 times BC, well, that's just BC. Okay, and then we're going to chuck that in the calculator. So 400 times the tangent of 65 degrees, 857.80. Let's see if I can remember it this time. So BC is about 857.80. Okay. Oh, and we're using meters. Okay, so I need to go ahead and label my units there. Okay, so pretty simple stuff. Let's do another few examples, or really, let's just do this last example just to keep this video short. The other video ran really long, and I kind of don't want to do that with this one. Okay, so let's say we want to find, so we know this height of this triangle is 4 kilometers. Let's say we want to go ahead and find the missing hypotenuse. We'll do that first. So we're looking for xy, and if we do the math, okay, if we do the math, 36.87 degrees, we take that away from 90, so 36.87 degrees, take that away from 90, 53.13. Okay, so these are some ugly angles. Okay, so again, we're looking for the missing hypotenuse here. So we're going to say, I don't know, let's go ahead and just use this angle here, the 36.87. I like that angle a little bit better. And we're going to go ahead and use cosine of 36.87 degrees is equal to adjacent over our hypotenuse. Okay, and we just put this all over 1. We end up with xy times the cosine of 87 is equal to 1 times 4, which is 4. Divide on both sides by cosine of 87. Okay, can't forget we're using degrees here. So our final answer is simply going to be, let's move this guy over here now. Okay, so our final answer is simply going to be, so I'm going to hit Control, divide. I have 4 over trig button cosine of 87 degrees. Okay, that is going to give me a rather giant number. Okay, and that can't be right. Oh, it's because I'm stupid and I put 87. I have no idea where I got 87 from. Okay, in my defense, it's kind of late at night right now and I'm really sleepy. So I put 87 instead of 36.87. So that should be 36.87. Okay, so that means segment XY is equal to 4 divided by cosine of 36.87. What is the matter with me? Okay, let's try that again. So I'm going to go up, recopy this. And of course, I'm going to say 36.87 this time. Yeah, I thought that was way off. Oh, so we get a hypotenuse of 5. So x, y is actually going to be equal to, we'll say 5 kilometers. Well, this awfully looks familiar, right? So remember, I always told you on 3, 4, 5 right triangles, the angles were always approximately 37 degrees, 36.87 to be a little bit more exact, and approximately 53 degrees, 53.13 to be a little bit more exact. Okay, so just to prove a point, let's do one more to find this missing short leg. Okay, and I'll go ahead and use green here. Okay, so I'm going to use this angle here. And I'm going to do, let's do tangents. So tangent of 53.13 degrees is equal to opposite over adjacent, which is unknown, xz. Okay, cross multiply xz times tangent of 53.13 is equal to 4. Divide by tangent on both sides. Okay, and we check that in the calculator. So now I'm going to say control divide, and 4 over trig button tangent 53.13, and we get something incredibly close to 3. Okay, so, and there you have it. So this is where these angles are coming from. So XZ is very, very close to 3 kilometers. Right, and there we have it, the ratio of 345. Okay, so now we see a more exact estimate of what these angles are supposed to be on a 345. Okay, so I'm going to cut this video short right there. Pretty simple stuff to try and do. Nothing really different here. If you need me to clear anything up or need to see more examples, or if you just want another video over this, just let me know. Shoot me an email. Otherwise, goodbye.